Okay. Some students have been asking about getting a unit circle review. Just maybe you've seen it all last year, but I don't know if you guys all got a chance to memorize it or whether it's been a while since you've seen it. So you can turn to this Trig review handout that I gave, if not yesterday, then the day before. Is anybody missing this? Because on the back of it, there's a half sheet with unit circle, one filled out, and one that is Anybody missing the sheet? Okay, so if you guys can turn to the back, there's a filled out unit circle. There's one that's blank. I'll go through the one that's blank. Yeah, just want to make sure where you feel like you're comfortable filling out the unit circle and understanding where these how to use it to find sine, cosine, and the other trig functions ratios. Okay, so to start off, I will say the most important values are here in the first quadrant. Okay, really it's just three variations. Okay, you have. And then we're just gonna do this in terms of radians. Degrees is really not that important in this course. Everything is in terms of radians for the most part. So most important measures are pi over 6, pi over 4, and pi over 3. Okay. So basically all the other variations are just one of these three. Okay. Now starting off, order pairs. They all follow a nice pattern here, starting with the upper left corner. Every denominator has a 2. And you're just going to start at the upper left corner and just start counting. 1, 2, 3. 1, 2, 3. You have the sheet down. Next up, we take the square roots of all the numerators. Technically, we're taking the square root of 1, but then 1 is just going to be 1, so we leave that alone. Okay, everybody good with that? The x value refers to the cosine, and the y value refers to the sine. So if I want to find cosine of pi over 3, it would just be 1/2. Sine of pi over 6 would just be 1/2. Sine of pi over 4 would just be root 2 over 2. Okay, next thing that I want to go over are the measures along the axis. So here we start at 0 degrees, or sorry, 0 radian measure 0. Up here, 90 degrees, the same thing as pi over 2. Over here, pi, and then below 3/2 pi, or 3 pi over 2. And also, if we circle all the way around, we can also think of this as 2 pi. All these order pairs are going to be 1 unit away from the origin, so we call it a unit circle because everything is 1 unit away. So that means this order pair is going to be 1, 0, 1, comma 0. This order pair is 1 unit on the y-axis, so 0, 1. Negative 1, 0. And then finally, 0, negative 1. Okay. Think of all these as just fractional values. So this is 0 and 2. This is 1/2 or 0.5. This is obviously just 1. Pi is just 1 pi. And here, think of that 3/2 as 1.5. Now, I think what students find the most daunting about unit circle is all these radian measures, right? 2 pi over 3, 5 pi over 6, like where do they go, right? So all these fractions, we just have to make sure that these fractional values are in the correct spaces, right? If a fractional value is between 0.5 and 1, then it should land somewhere in the second quadrant. If your fractional value is between 1 and 1.5, it should land in the third quadrant. If your if your ratio value is between 1.5 and 2, your radian fractional value is between 1.5 and 2, then it should land in the fourth quadrant. Okay. Now, all of the variations you're going to see are all going to share either a denominator of 3, a denominator of 4, or a denominator of 6. So I'm going to start with the easiest one, or the ones that's easiest to spot, and that's the pi over 4. So all the middle ones, the middle measures, the ones that are between, they all will be with a 4 in the denominator. Okay. And right now, let's not even worry about pi. I think sometimes we see pi and we just kind of throws us off, right? Just think in terms of the fraction. This is 1/4. Okay? And we're just going to keep adding 1 to the numerator and make our way around the unit circle. Okay. So 1/4 plus 1/4 is, we might see duplicates. If we see duplicates, we're just going to skip over it. Okay. So 1/4 next is 2/4. That's the same thing as 1/2. What's next? 3/4. There's an open slot there, so that's 3 pi over 4. So 1/4, 2/4, 3/4. What's next? 4 over 4. That's just 1, so we skip that. That's already filled out. Plus 1/4, 5/4. Yeah. Plus 1/4 is 6/4. That's 3 pi over 2. We can skip that. That's already filled out. Next up, 7 over 4. And then finally, 8 over 4, which is 2 pi, and we stop. Okay, next up, let's do the ones that have 3 in the denominator. So basically, just understand that anything with a 3 in the denominator is going to be the ones that's furthest away from the x-axis. Okay, furthest away from the x-axis. So that means these here. All of them will share a denominator of 3. Okay, so think of pi over 3 as just 1/3. Okay, we're just going to keep adding 1/3 to get to the next spot. 1/3. What's next? 2/3. That's an open slot there. We'll fill that in. Next up, 3/3. That's a duplicate. We skip over that. Next up, what's after 3/3? 4/3. We have an open slot. Next up, 5/3. We have an open slot. Plus 1/3, 6/3. That's 2, so we stop. Finally, we have the 6 in the denominator. Anything with a 6 in the denominator are going to be radian measure that's closest to the x-axis. So I'm going to highlight them. These are the ones closest to the x-axis. We're going to see a bunch of duplicates, but it's okay. If we see duplicates, we'll just skip over them. Okay. 1/6 next is what? 2/6. That's duplicate. 3/6. 4/6. 5/6. Okay, there's an open slot. 5 pi over 6. Okay, 6 over 6. 7 over 6. Okay, there's an open slot. 8 over 6. 9 over 6. 10 over 6. 11 over 6. Okay, open slot. And then finally, 12 over 6 is 2, so that brings us back full circle. So now, okay, all the denominator with 4, or all the ratios with 4 in the denominator, or radian measure with 4 in the denominator, will all have a numeric value, same order pair, root 2 over 2, root 2 over 2. The signs will be different, but at least we know the numeric value is there. So I'm just, anywhere I see 4 in the denominator, I'm going to copy this order pair over. So over here, right? Anything with a 3 in the denominator will have order pair 1/2 or 3 over 2. So anytime I see a 3 in the denominator, I'll just copy that order pair over. Any order pair or any radian measure with a 6 in the denominator will all have root 3 over 2, 1/2. So I'll copy that over. Anything with a 6 in the denominator. Now, last thing to do is make sure that our signs are in the right slots. Think about quadrant 1. Quadrant 1, everything is positive, positive. Second quadrant, all your order pairs will have a negative x value and a positive y value. So we're going to make that adjustments. Change all the x values in the second quadrant to be negative. Third quadrant, all your order pairs will be negative, negative. So that means we want all of our order pairs to be, all x and y values to be negative, negative. And the fourth quadrant is positive, negative. So we keep the x positive, but we change the y to be negative. Okay, so we make that adjustment. Second quadrant, we want all the x values to be negative. Third quadrant, we want all the x and y values to be negative. And in fourth quadrant, we want just the y values to be negative. Okay, so there we have it. Fill out the unit circle. Hopefully you feel like it's just a minimal amount of memorization that you have to know, and the rest you're just following the pattern around the circle, adding fractions and copying and understanding what the signs are going to be with each quadrant. Okay, so anytime I'm looking for cosine, it's the x value. Anytime I'm looking for sine, it's the y value. Anytime I'm looking for secant, let's say I want to find secant of pi over 3. You know secant is the reciprocal of cosine. So secant of pi over 3, find cosine first, and then flip it. Right? So secant of pi over 3 would just be 2 over 1. Sine of pi over 3, sorry, cosecant of pi over 3 will just be taking the y value and flipping it. So if I know sine of pi over 3 is root 3 over 2, then the cosecant of pi over 3 is going to be 2 over root 3. And finally, tangent. Tangent is just going to be y over x, or in other words, sine over cosine. So let's say I want to find the tangent of pi over 3. I would do y over x, but then to make it easier so that you don't have to deal with the complex fraction, cover up the denominator, and you're just going to do y over x with the numerator. So root 3 divided by 1, y over x, just root 3. Okay. So if you just cover up the denominator and then just do y over x, that's going to be your tangent value. If I'm looking for cotangent, then cotangent is just going to be the reciprocal. It's just be x over y. So if I want to find the cotangent of pi over 3, cover up the denominator, and I just go y, x over y. So 1 over root 3. So that's the cotangent of pi over 3. Okay, so hopefully that review was beneficial to those of you who needed a recap of unit circle. Okay, so let's go to review worksheet. This is on page 13. Actually, before we do this, let's review our trig derivative rules. I want to go through the patterns with you and then see if you can write down the rules from memory just as a way to practice before we get to our quiz Tuesday after break. So let me go through the patterns and then going to have you ask you to recreate it and see if you can begin the process of memorizing these rules. Okay, so first thing is I like to create two columns. Okay. The second column is where a nice pattern is going to develop. The second column, they all are going to be trig functions that start with C, and they're going to be written in alphabetical order. So COS, COT, CSC. Okay. Sine is first. That's always the first trig function we think of, right? So sine and cosine is the first row. Cotangent and tangent are they're reciprocals of each other, so I put them next to each other. They also are going to have nice patterns that are similar to each other. And then secant and cosecant, I put them last. Okay. So first column, second column. Sine and cosine's derivative, they're basically involving each other. So there's that nice symmetry there. Tangent and secant, their derivatives only involve each other. So tangent's derivative is secant squared. Secant's derivative is just secant tangent. And there's a nice symmetry on this side as well. Cotangent and cosecant also involve just each other for their derivatives. Cotangent, we're just going to take that cosecant and square it, right? Very similar pattern between tangent and cotangent. Just look at the function below and square it. Secant's derivative is just the one above it and itself. So secant u tangent u times u prime. Same thing with cosecant. Cosecant's derivative is just itself and the one above it. Negative cosecant u cotangent u times u prime. And then the final pattern, what do you notice about all the trig functions that start with C? They all produce negatives. So that's nice. All the negative derivatives are just lined up on the right side. Okay, so spend a minute, look over this. Then I'm going to cover this up, have you guys copy down the unfilled out rules and see if you can recall them on your own. Okay, just as practice. Okay, so just spend a minute looking over that before I have you guys try it. And again, I just want to point out that even though this looks like it's only 6 rules, there's actually 12 rules that you're looking at, because next semester we're doing antiderivatives, which is going to be undoing our derivative rules. So working from the right side to the left, that's the integral rule. So if you know this, you basically are memorizing 12 rules that will be helpful for next semester as well. Okay, let's go ahead and try these. I'll cover this up. Here we have 6 trig functions. See if you can recall them from memory, their derivatives. Okay, let's check our rules, see if we got them. Okay. Even if you didn't get everything right, at least we had a chance to kind of have a run through, and we can do this again on Monday after the break. Okay, let's turn to worksheet 2. And I don't think we got through all of number 1, right? Did we? We didn't. Okay, so let's go through this problem here. Understand that this is basically, you would treat this the same way as if you saw square root of x cubed. Right? Just imagine this is a much larger variable, but you would write this as x to the 3/2. So same idea, you would write this as bracket cosecant 7 minus pi x raised to the 3/2. Okay. Chain rule, so you want to identify your outside, inside, and inner, and take turns with each derivative. Outside function is that bracket to the 3/2. Inside is the cosecant parentheses. And the inner portion is that 7 minus pi x. All right, we take turns with each derivative. Bracket to 3/2 becomes 3/2 bracket to the 1/2, right? Bring down the exponent, subtract 1 from the exponent. Leave the inside function intact. In a separate space, we're going to take care of cosecant's derivative. Cosecant's derivative is negative cosecant u cotangent u, with the inside inner portion intact, unchanged. And then finally, a separate space to take care of the inner function's derivative. 7 minus pi x becomes 0 minus pi, right? 7 goes to 0. Negative pi x becomes negative pi. So we're left with negative pi. So each derivative is kind of sprawled out. They're all chained together by multiplication. We don't want to insert them inside one another. We want to put them all in their own space. And finally, we can do a little bit of cleanup. 3/2 times negative pi times negative 1. We can multiply all that out to be just 3 pi over 2. And these are both like terms. If I multiply these together, I just add the exponents. 1/2 plus 1 is the same thing as 1/2 plus 2 over 2, which is 3 over 2. Okay, any questions with 1? Okay, take a look at number 2. So look at how number 2 is set up. What rule is involved if we want to find the derivative? Good, quotient rule. Okay, so let's set that up. F prime g minus fg prime all over g squared. Cosine of u becomes negative sine of u times u prime. Keep the g minus, keep the f. When we get the g prime, cosecant becomes negative cosecant u, cotangent u times u prime. Oh, something about ex here. Ex is not the same thing as e to the x. Think of ex like you would if it was like 5x or 7x or 10x, right? It would just be the coefficient. So 5x would turn into 5. Same thing here. Ex would just turn into e. Another option that you could do is you could turn this into product rule. Cosecant is the reciprocal of sine, so you can make this cosine times sine and then go through product rule. Okay, if you do that, that's the way I worked it out on my key on the back page. But here I'm just going through using quotient rule. So either way is fine. And maybe it's a little messier looking on the quotient rule side of things, but just different variations. Yeah, that's what I did later on. I factor out the cosecant, and then I made it a little bit cleaner. You can take out a cosecant and then change that cosecant to be from cosecant squared to cosecant. Yeah, I noticed that a little bit later. But yeah, we can make it a little bit cleaner that way. Okay, any questions with 2? All right, take a look at number 4. We're going to skip number 3. Let's go to number 4. Number 4 says x cosine of y equals tangent of y minus 3x. Look at how this equation is set up. We're asked to find the derivative. What process do you see involved with this equation? Product and implicit. Okay, implicit, I think that's easier to spot, right? You see y's all over the place. You know you're going to have to keep track of your dy dx. I think the issue is recognizing that product rule. Sometimes we want product rule to kind of announce themselves. We want 2 sets of parentheses next to each other. Here it's kind of hidden, right? Just x cosine y. It feels like it could be just one term, but that's actually 2 terms sitting there, right? And recognizing that and applying product rule is important. So try that. You know, you got to go through product rule for the first set, and then you can take care of those standalone terms on the right side. Okay. F prime g plus fg prime. Your f is your x, and your g is your cosine y. Try that.
Okay. For number 2, could you pull out a cosecant of EX from the whole thing?
Yep, yeah.
And then make the bottom just cosecant of EX?
Yes, yeah. Yeah, I tried to do that over here, but yeah, I recognized that last period after I realized I could have gone a little further. But yes, we can factor out even more, make it even cleaner, take out the cosecant EX, and take out the denominator term as well. Okay, so here's number 4, f prime g plus f g prime, x becomes 1. We keep the g function unchanged, back to f, and then when the g prime, cosine becomes negative sine of u times u prime, so therefore negative sine of y times dy dx. So this is where we got to keep track of our dy dx. So product rule comes first, and now we can move to the other side of the equation, standalone terms. Tangent becomes secant squared y times dy dx, and 3x becomes 3. Okay, that's the hard part. Once you get to that step, then your calculus is done. You're just trying to rearrange, add, subtract, right? Group your dy dx terms together, factor it out, just try to isolate dy dx. I see 2 terms with dy dx. I'm going to just move them, add and subtract them so that they are sitting next to each other. The non-dy dx terms are going to be grouped on the other side of the equation. Factor out dy dx, and then divide over. Now, depending on where you group your dy dx terms, whether it's on the left side or the right side, your positive and negative signs may look a little different. So just understand that there may be different variations to the answers, which is fine. I'll take any variations that's correct. But also to let you know that on the AP exam, let's say you've got to one answer and you're looking for your answer choice on the multiple choice section. And all you see is this right here, right? Understand that your version may not be showing up on the answer choice, even though it's correct. So sometimes the way to resolve that is multiply the numerator and denominator by -1. See if doing that will convert it into a different form that will match with an answer choice that's available. So I just want to kind of show that to you. If my answer choice came out all negative, but if I multiply numerator and denominator by -1 through top and bottom, I would get this variation. These, even though they look different, they're actually the same. Either think of it as factoring out -1 or multiplying a -1 through top and bottom. Okay, take a look at number 5. Okay, so number 5 says velocity is 2 tangent cubed x. Find a of t. To find a of t, I have to find the derivative. To find the derivative, what is involved here? Good, right? We obviously have to involve tangents rule, but there's also chain rule. So what can we do to make it easier to see the chain rule portions involved, or the chain rule layers. Let's get that bracket to show. Let's get that cube to sit nicely outside that tangent. Now, when you pull that 3 outside, make sure that the bracket does not include 2, right? 2 is outside the bracket. And then go through chain rule. Once you go through chain rule, you'll be able to get to acceleration. And then once you get to acceleration, you can replace all the t values with pi over 4. And that's why I wanted to review unit circles so that you'll be able to kind of practice evaluating with unit circle values. Chain rule, you got the outside portion, you have the inside portion. So take turns with each derivative and put them next to each other, not inside each other. Okay, let's see what our chain rule looks like here. Two bracket cube becomes 6 bracket squared. Secant squared, or tangent becomes secant squared. So there's our derivative. I like to get the exponents outside the set of brackets because I know the next step is inserting the t value. Sorry, I changed it in terms of x and then realized it and changed it back to t. So it should all be in variable t here. Once I got my acceleration function, then I started inserting pi over 4. And then start thinking about unit circle values, right? Tangent pi over 4, that's going to be just 1. 1 squared is 1. Secant of pi over 4, we know that secant is related to cosine, so think about cosine first. Cosine of pi over 4 is root 2 over 2. You flip that, we get 2 over root 2, and now you're just down to a bunch of numbers. Combine it down to a numeric value. Acceleration is 12. Okay. One final problem, number 6. Try number 6, similar process. You may need to rewrite it in, to help you with the chain rule recognition. But number 6 is a tangent line equation, so you know that your derivative is going to help you get to the slope. You know that your original function is going to get you to the y value, order pair, slope, then point slope form. All right, everybody good with 5? Okay, last one here, number 6. Get that bracket to allow you to see the outside, inside, and inner. Outside portion is the 2 brackets squared. Next one in is secant parentheses. And finally, the innermost function is that 2x. Take turns with each derivative. This becomes 4 bracket to the first power. Next space over, secant becomes secant tangent. Secant u, tangent u. And finally, innermost portion, 2x becomes 2. And they're all are going to be expanded next to each other, not inside one another. Right? Do a little bit of cleanup, merge some terms together, push coefficients together. 8 secant 2x squared tangent 2x. Okay, we have our derivative, we have our function. We can now involve that pi over 6 to help us get to our slope and to our y value. So I'm going to start by putting that pi over 6 into the original function. Now, you may be looking at, I took a bit of a shortcut here. That pi over 6, the reason why that pi over 6 turns to pi over 3 is because of that 2x. Okay, so let me show that step that I skipped over. So if I insert pi over 6 into secant of 2x, that 2x, that 2 times pi over 6 will multiply to be 2 pi over 6, and 2 pi over 6 reduces to pi over 3. And that's why all the radian measures all convert to be pi over 3, because that 2 in front multiply with that pi over 6. So secant of pi over 3, think of secant as related to cosine. Cosine of pi over 3 is 1/2. Take the reciprocal of 1/2, which is 2 over 1. There's my secant value. 2 squared is 4. 4 times 2 is 8. That's my ordered pair. That's my y value. Next up, derivative. Take my derivative. Replace every t value with pi over 6. That 2 times pi over 6 will change it to be pi over 3. We look at our values individually. Secant of pi over 3, same thing as cosine, or related to cosine of pi over 3, which is going to be 2. Tangent of pi over 3, that's y over x, your order pair. Root 3 over 1 is just root 3. We get 8 times 4 times root 3, which is 32 root 3. And then point slope form. Okay, any questions here? Okay, so hopefully you guys have a good feel for what to expect on the quiz. Monday after we return, we'll review our derivative rules again. I have another worksheet. We'll practice that through. And then Tuesday is your quiz after the break. Thanks.
4 hours and 45 minutes.
You don't gotta say it, you don't gotta point it out.
So all I can is, like the average SAT